Joseph jogs from one end A to the other end B of a straight 300-meter road in 2 minutes 30 seconds and then turns around and jogs 100-meter back to point C in another 1 minute. What are Joseph's average speed and velocity in jogging from A to B and from A to C? So we are looking at a linear motion wherein the person does thoda back and forth. So we have that's A and that's B, which is 300 meters apart, and back to C. So that's what he is doing, right? Okay, C is not, maybe over here, that would be better. So basically we're looking at A to B and then B to C. So this is what we are looking at. So this is around 300 meters. We have 2 minutes and 30 seconds. And this is around 100 meters. And he takes a minute to be at point C. So this is our scenario. Let's see what can we find. We have to figure out two things. I forgot to mark both velocity and speed for two different cases. So please don't forget when you are doing something like this. Questions are easy, but we miss out what we have to find. That has happened to me also, happened to my students also. So high possibility that it will happen to few of you at least. Okay. Point A, not point A, question A. We have the person moving from A to B. So in this case, what can you tell about distance and displacement? Distance and displacement are the same, and that is of 300 meters. I hope it made sense. It's a straight line, one to another end. Displacement is shortest distance between 2 points. So satisfying both this condition is your 300 meters. And time is 2 minutes 30 seconds. So we have 2 into 60 plus 30. So that would be 150 second. Okay, next thing is velocity, and we have average speed. Both are equal. Why? Because distance is equal to displacement. So we have this to be, say, change in distance and change in time. So in both the cases we have this to be of 300 and by 150, so that would be 2 meter per second. And now point B, from A to C. So we have the distance would be, now how to find? Is going from A to B and then back to C. So distance would be, first is A to B and then B to C. Just follow the path. That would be your answer. So this would be 300 plus 100, 400 meters. Now displacement would be what? See, displacement is nothing but shortest distance, that is from A to C. So that would be line segment AC, which would be equal to 200 meters, right? Oh yeah, we need to show how we got AC. We can't just write it AB, line segment AB minus CB. So you need not substitute and all of that. We can directly write this. Here I did substitute. To be frank, you don't need to do that. I mean, it's just a small calculation and you guys are in higher grades. So that's okay. You have drawn a diagram. You made it very clear. And yes, we are showing the calculation and everything. Like, in terms of equations. So this is good enough. Okay, now we know the distance and displacement. All we have to do is substitute, and we are done. So average speed we already written, right? Okay, I will just write it again because it was a different case, and now we have a different case. And so distance over here is 400 and the time is, I didn't find the time, is an array. So you guys can find the time. Difference in time would be, first is 150 seconds plus a minute. This would be equal to 10 seconds. And now we can talk about other things. Average speed. Other than 0, nothing else get cancelled. So 40 by 21 meter per second. You know my policy. Any such weird answer, I would let, any pure division, I would let you guys do it. I can't help you much over here. Approximately, it should be a bit less than 2. That is one thing which you can tell. Approximately a bit less than 2 meter per second. It's something that, okay, even you can tell. It's not that I can tell. So again, don't write this in your exam because this is, they would expect you to divide, to be frank. Then now we have velocity, which is your displacement by time. Displacement, I think it is, I forgot, 200. Okay, it's 200 by 210. So again here it is just 20 by 21 meter per second. And we have, what else? Okay, that's it. So what is that? One thing that I want to observe, make you guys observe here is, from A to B when we are moving, distance and displacement are same, so your velocity and average speed will be same. Whenever you have anything that is reversing, that is, a person goes forward and comes back, distance will be not equal to displacement, and so your speed and velocity will be different. So let me show that with our simulation. So let's switch on the simulation. Okay, so you can see the object going forward. Let me make it start reversing. First is I'm applying the brake, and now it will start going back, right? So this is us going back, running back, and so we will have our distance, which is 1400, right, at the end of 20th second, while our displacement time graph at the end of 20th second, it is showing to be around 270 something. Okay, so clearly they are not equal. If you just go forward, even though you slow down, let me show the next case. I'm going forward and I'll be slowing down, not going back, I'm slowing down. Let's see what happens with the distance and displacement. And let me start braking. Right, I'm slowing down, is it not? You can see distance versus time graph and displacement versus time graph. The graph looks the same. At the end of it, we have around 800-ish at the end of 9th second. So here distance and displacement are the same. Is it not? And you can see I am slowing down the velocity. You can clearly see over here. And the acceleration is also negative. So you're able to understand, right? Even though you're slowing down, distance can be equal to displacement. The condition is just this, that they have to be going forward. Whatever variation are there, increasing speed, decreasing speed, doesn't matter. Other than things coming back, only that is not okay for displacement and distance not to be equal. That's the only case wherein distance and displacement, not only case, but yeah, that's a particular case in what we are studying, wherein distance will not be equal to displacement, and so average speed will not be equal to velocity. Right, and this is your answer.